So question 16.9, I noticed a lot of people were getting that one wrong as well, and it's just a tricky question. And so you might just be reading it and going on a gut reaction and answering it before thinking about it a little bit more in depth or doing any calculations. So just to go over it, would a 1 times 10 to the minus 8 molar solution of HCl have a pH of less than 7, equal to 7, or greater than 7? And based on how people are answering it, I'm guessing you're remembering that because we have HCl, it's a strong acid, that essentially the concentration of HCl equals the concentration of hydronium. So you're probably reading this and saying, oh, if I have 1 times 10 to the minus 8 molar solution of HCl, that equals my concentration of hydronium. So I have 1 times 10 to the minus 8 molar hydronium, and you're probably just taking, because we know pH equals the negative log of hydronium, you're probably just taking that concentration, taking the negative log of that, and finding that you have a pH that is greater than 7, and then getting the answer wrong. So the issue is, and I talked about this in class a little bit, was that for the most part, you can just take the concentration of the acid as dictating the pH of the solution, except at low concentrations. And I remember for neutral water, we had the expression where Kw equals hydronium times hydroxide, and we found that in neutral water, due to the autoionization of water, this Kw was 1 times 10 to the minus 7 in hydronium, and 1 times 10 to the minus 7 in hydroxide. So for this question, because our concentration of HCl is so low, we actually this is a case where we do have to take into account the concentration of hydronium just from the autoionization of water. And so let's look at that. Here's our hydronium concentration from water and from HCl, our hydronium concentration. So we have from water, we have 1, 2, 3, 4, 5, 6, 1. And then for HCl, we have 1, 2, 3, 4, 5, 6, 7. So here's our concentration. So to get our total concentration of hydronium that we need to calculate pH, we can simply add those both together to get 1, 1, which is basically H3O plus equals 1.1 times 10 to the minus 7 molar. So now we have the concentration of hydronium. Now we can calculate the pH. And so here, pH equals the negative log of 1.1 times 10 to the minus 7. And we take the negative log of that, pH equals 6.96. So the pH is acidic, it is less than 7. So the only reason you were probably getting it wrong is because you were just taking the concentration of HCl as the concentration of hydronium. But because the concentration is so small, we cannot, in this case only, we cannot ignore the autoionization of water. In this case, the autoionization of water actually produces a higher concentration of hydronium ions in solution than the strong acid. So as a result, we had to add those two concentrations together before we could calculate pH. And now that we've done that, we can see, yes, we do have an acidic pH. It's just below 7. It's a pH of 6.96.